Let's do some examples that are inside. So here I have inside that f of x. So you see that plus 2 is inside the f of x. So this is inside, so this is going to be side to side and opposite. We see that this is adding, so that means it's going to be a shift. And it's left to right, but opposite, so that plus is actually going to be left 2. So we want to shift left 2 because we're adding 2 in it, because it's inside, it's the opposite direction we would think it should be. So I have the same original one I was working with in the last videos. There's my dashed, my original graph. I want to shift all these points left 2. And you'll notice as you're moving all these points left 2, that the y coordinate point is not changing. It is only the x coordinate point that is changing left 2. So let's try this one. We have a negative that is on the inside. So this is still going to be side to side and opposite. This is a negative, a multiplying by a negative. So we know that this is a reflection. A reflection side to side. So across the y-axis. So we take our original and we're going to reflect it side to side. So this point can't reflect that side to side because it's right at the center y-axis line. This can be reflected across, this can be reflected across, and this can be reflected across. And there's our new function. Everything's been reflected side to side. Let's try some scalings last. So these ones are very similar to the last video, except these ones are both inside. So now instead of stretching it vertically, we are stretching horizontally. So this one is inside, we're multiplying, so we know it's a scaling. And like we just said, because it's inside, it's side to side, so this is going to be a horizontal. And usually we would think this is 2 times as wide, but remember inside is opposite. So this is actually going to be half as wide. So this is actually a horizontal shrink because inside is opposite. So we take that number and flip it. So this one is also a scaling, but because it's opposite, it's not half as wide. It's going to be 2 times as wide. Because that inside one is always opposite. So this is our horizontal stretch. So let's try this out. Here's our original in dashes. First thing I want to do is make all these points half as wide. So now we're looking at the distance to the y-axis, how wide it is. And I want that distance to be half as much. So this distance is 2 blocks. Times that by half is 1 block. By the way, I forgot to say, this one is still just going to stay where it is because it's at 0. Half times 0 is still 0. This point out there is 4 blocks out. So times that by half. So now it should be 2 blocks out. Right there. And then this point is 1, 2, 3, 4, 5 blocks out. So 5 times half is 2.5. So 1, 2.5. Notice that the height, the y coordinate, doesn't change. All you're doing is bringing the points closer to the y-axis. You're changing how wide they are. So there's my graph. And you can see that that graph is half as wide as the original. Now let's try twice as wide. So again, this point isn't going to change because it's at 0. 2 times 0 is still 0. This point is 2 blocks wide from the y-axis. So we're going to times that by 2 to make it twice as wide and takes us out to here. this one is 4 blocks wide, so times that by 2, and we're going to get 8 blocks wide. And then this one is 5 blocks away from the y-axis, so times that by 2, and we get 10. So here's our graph, and then you'll notice it is twice as wide as that original dashed graph. So that is how we work when they're inside. We have an example of a shift, a reflection, and a scaling for you. In the next video, we're going to start to do multiple transformations at the same time, and we're going to start working with our parent functions. And we'll see how that works.